We now demonstrate how to calculate measurement of forecast error. In this demonstration, we have 6 data points: month 1, 2, 3, 4, 5, 6. We have 6 actual data points. At the same time, we assume the demand forecast for each single month will be 1,000 for simplicity. Okay, now our objective is to get the value of mean absolute deviation, MAD, and the mean absolute percent error, the MAP. And at the same time, we would like to observe the tracking signals. Now let's start the calculation. The first one is to get the deviation, which will be equal to the actual demand minus the forecasted demand. And we say yes. After that, we just pull down the shell to fill all data points. So we have the deviation for every single month here. The running sum of forecast error is to sum the deviation of all previous months. For the first data point, we have only 1 month, and they'll be equal to month 1 deviation. For the second data point, that will be the new data point plus the sum of the previous data point. And we have 20 for this data point. And we just put it down to obtain the running sum forecast error for every single month. The absolute deviation value will be equal to absolute. We call the function of ABS absolute value of the deviation point, and we say yes. Again, we put it down to obtain the absolute value for every deviation. The sum of absolute deviation will be equal to the sum of the previous data point, right? Of the absolute deviation. For the first point, it will be equal to month 1 absolute deviation. For the second one, that will be equal to the new data point plus the previous one. And we say yes to get the second data point for the sum of absolute deviation. And we put the data point down to fill all cells. And this will be the sum of absolute deviation in the end of each month. The MAD will be equal to the sum of the absolute deviation divided by the number of the month for that data point. In this case, we have the 1, 2, 3, 4, 5, 6 for each month. So we can just call the number of the month. Here, I would like to remind you that if the month number is not starting from 1, we need to be careful to input the number of the month here, okay? So instead of B5, we probably need to put 1, right? We need to put 1. But given that we already have 1 here, so we want to, for simplicity, call the cell, and we fill all cells for the data point. So we look at the last data point, and that is sum of absolute deviation divided by 6, okay? So that is our MAD. So here, in the MAD value, we can make it equal to the last data point, right? And that's our MAD value. The tracking signals will be equal to running sum of forecast error divided by MAD. So we have that data point. And then we just fill all cells to get the tracking signals for every month in the last 6 months. The MAP value will be equal to MAD divided by the average demand. Before we get the MAP, we need to get the average demand will be equal to average actual demand. We call all of them. And we say yes to get the average demand in the past 6 months. So now we are ready to get the MAP value will be equal to MAD divided by the average demand. So we get the MAP value. So let's make it a little bit more straightforward. Okay, so we get the MAP value. It means the MAP value will be 6.43%. Now let's look at the tracking signal graph. As we can see there, the tracking signal show a pattern of almost continual increasing over time. This actually is a concern for us if we have a continuously increasing tracking signals like this. The reason we have this is because we make up the demand forecast in a simple way. Ideally, we would like to see the tracking signals randomly distributed among the zero line over here, the zero horizontal line, okay? Randomly distributed along here. Whenever you see a continual increasing tracking signal like this or decreasing tracking signal, you should raise a concern about the quality of forecasting. Okay, that's what we have demonstrated for how to calculate measures of forecast error. Thank you.